Alright guys, this lesson I would like to talk about rate and differentiation. So I'd like to show you what happens if the first derivative is positive or negative and then combine it with the second derivative if it's positive and negative. What happened to the interval. Okay, so if a quantity varies over time, then we can differentiate to find the rate at which is increasing or decreasing at each time t. And then we can differentiate again to find the rate at which the rate is increasing or decreasing. So this is an example of, if we differentiate the displacement function, we're going to get the velocity function. And then if we differentiate again, we're going to get acceleration function, which is the change in velocity over time. Okay? All right, so let's have a look at what happens if if the f dash x or a first derivative is positive or negative. All right, so firstly we'll talk about increasing and decreasing in an interval. So increasing and decreasing in an interval. All right, so what does that mean? So for example, if we have a graph like this, and this graph looks like this way, this is the starting point and that's the end point. All right, say for example, this is the t, and that's just any letter I can use. I can just say that's a p. All right, now we call that interval from the point here. All right, let's call this the point A, and that's point B. From point A to point B, that interval, the graph is always increasing. All right, so the function f(x) is called increasing in the interval because every chord within the interval slopes upwards. All right, so what does that mean? So that means if I choose any two points, all right, so that's not a really good diagram because it's not really increasing here, so I have to do a better diagram. All right, so this diagram here. All right, now if you look at that, if I choose any two points, a point here and a point there, all right, and then connect them together, we call that it's a chord. And then this chord, within the intervals, as you can see, the line is increasing, all right? So from the bottom left to the top right. So the line is increasing and the gradient of this line is positive. And then we can call this point is A, that is B. So the proper definition is if the function f(x) is called increasing in the interval, if every chord within the interval slopes upwards. So that is if A is always less than fb, all right, for or a less than b, all right, in the interval. All right, so if it's decreasing, then it's different way around. So the function f(x) is called decreasing in the interval if every chord within the interval slopes downwards. So when you connect any 2 points on this interval, then you will see the line is always decreasing or having a negative gradient. Okay, so I'll just show you an example here. All right, so we've got an interval going this way, for example. All right, and then if you just pick any 2 points, so a point here and a point there, and then if you connected these 2 points, you will see that the line is decreasing. And let's just call this as A, that's B. So that's P, here's the time. All right, so the definition tells you that if A, in this case, is always greater than FB, so the y coordinate for the point x equals to A is always greater than the y coordinate for the point 1 x equals to b, okay, for or a less than b in the interval. All right, so this is actually pretty easy to understand because you have learned the differentiation in the previous topics. Now we'll talk about concavities, all right, concave up and concave down in the interval. How do we know if the interval is concave up or concave downwards? All right, graphically it's really easy to understand from here. All right, so concave up or concave down. Oops. So concave up and down in an interval. All right, So, concave up or concave down interval. How do we know? And let me just draw the diagram first. Alright, so we have an interval like this. This is still P, here is still T. Now, as you can see here, this graph is concave upwards. So the graph is concave up in the interval because every chord in this interval lines above the curve, all right, above the curve. So every chord, all right, so if I just pick any 2 points on this interval here, and then you join them together, as you can see, this chord is above the graph, all right, above the this function here. So that's why we call that a concave up, all right. And the significance of this is, you know, later we can talk about this is, you know, it's increasing, or something is increasing at an increasing rate. Okay, I'll talk about this later. All right, so the function fx, so fx, all right, is called concave up all right, in an interval if every chord within the interval lines above, okay, so this is really important, lines above the curve. All right, so then we call this fx is concave up in that particular interval if every chord within the interval is above the curve. All right, so we can pick another 2 points, for example, a point here and a point there, and as you can see, this chord is again above the original curve. All right, so the concave downwards is really easy, it's just the opposite. All right, if the curve is concave downwards, then every chord within the interval lines below the curve. All right, so an example of that. That's T, here's P. So this is concave downwards, and then if you just draw in any 2 points on this curve here, you can see clearly this is, you know, below. All right, so it's really simple. All right, so I'm not going to write everything down, okay? All right, it just, oh well, okay, how about we just write it? Concave downwards in an interval if every chord within the interval lines below the curve. All right, now if I want to combine all these 2 pieces of information, combine it together, then we can form another 4 very important things. So increasing or decreasing at increasing or decreasing rate. Okay, so we're talking about what happens if the first derivative is positive and the second derivative is positive, or first derivative is positive and the second derivative is negative, and we do have 4 different cases. So let's talk about this. All right, this is going to be interesting. All right. Okay, all right, so increasing or decreasing at increasing or decreasing rate. So let me write this one down. Increasing or decreasing at an increasing or decreasing rate. So it's like, you know, you can increase your speed at a decreasing rate. So acceleration is like slowing down, but your speed is still increasing, all right? But it's not increasing at an increasing speed, but it's increasing at a decreasing speed. It's a bit confusing, but later I want to start to do the questions so we understand a bit more about that, okay? So the first case is increasing at an increasing rate. So something is increasing, and also at an increasing rate. So the second derivative is also positive, means the curve is concave upwards. All right, so that's the first case. I'm just going to use a different color so we can color code it. All right, so the first one is increasing at an increasing speed or increasing rate. increasing rate. All right, so that means we have increasing here means the rate is increasing, so f dash x is positive. All right, which means fx is increasing in the interval. Okay, and then at an increasing rate tells you that the second derivative is also positive. All right, not equal to 0 but positive, greater than 0. So increasing the increasing rate. All right, so the next one is increasing at a decreasing rate. All right, increasing at a decreasing rate. Yeah, right. So eventually, the object, if it's moving, then an object is increasing speed and a decreasing rate. That means the rate of increasing speed is going to eventually become 0. So it will be just, move in a constant speed eventually. All right. So increasing and decreasing rate is, well, firstly, that's increasing. So the first derivative must be greater than 0, or you can say the curve is always increasing within the interval. However, decreasing rate means the second derivative is less than 0. All right, so that's the next one. All right, so we've got 2 more. What about decreasing at an increasing rate? Right, so decreasing and increasing rate. Now, firstly, decreasing means the first derivative is less than 0. The curve is decreasing within the interval. At increasing rate means the second derivative is positive. All right, so it's concave up, but it's decreasing in a concave up fashion. All right, eventually I'll show you the graph so you will understand a bit more. All right, so the last one, let me pick that color here. The last one is decreasing at a decreasing rate. So decreasing, first derivative is less than 0, and the second derivative for the decreasing rate, the second derivative is also less than 0. Okay, so let me draw the graph, all right, so you will understand a bit more about this. Now, increasing and increasing rate, you can see the graph looks like this, okay? Let's use this color here for the coordinate axis. Oops. All right, so we've got our coordinate axis here. Now, increasing at an increasing rate, the graph looks like this. So the graph is increasing, and it's concave upwards in the meantime. So this is what, oh, that's not what I want. That's what I want, okay? The graph is increasing, and also the graph is increasing at increasing rate. So the easiest way to do that is we pick a point here, and you draw a tangent, and then you pick a point there, you draw another tangent, then you can see the slope, the first slope is less than the second slope. All right, so the gradient of the first line is less than the gradient of the second line, which means it's increasing at an increasing rate. Okay, hopefully that makes sense. So I'm just going to say the grade M1 and M2, and then M1 is less than M2. So we're talking about the gradient here. Next one is increasing at decreasing rate. So the curve is still increasing, but the rate of increasing is decreasing. Hopefully that makes sense to everyone. All right, so if I pick any 2 points, one is above, all right, the other one is just the one after, all right, and then you look at M1 and M2. The gradient of M1 is actually greater than the gradient of M2. So you can see the speed, or if we talk about speed, then you can see the speed is sort of like, the rate of increasing speed is decreasing, okay? All right, next one, decreasing at increasing rate. Here's the graph. All right, decreasing, okay, at increasing rate. Yep. And pick any 2 points. You can see gradient M1 and gradient M2, so M1 is less than M2. All right, so the last one is decreasing at a decreasing rate. Okay, decreasing at a decreasing rate. And then points here and point there. All right, so that's M1, that's M2. And M1 is greater than M2. All right, so let's just put this one into the current situation. All right, we'll talk about coronavirus increasing rate. Which graph you want to see? Okay, I'll give you some time to think about it. If we're looking at the rate of people getting infected by coronavirus, then what is the type of graph you want to see in the future? Do you want to see an increasing rate graph? I don't think so. Or do you want to see people still we still have an increasing amount of people getting the virus, but a decreasing rate? What does that tell you? Okay, and then do you want to see a graph that's decreasing and increasing rate? Or do you want to see a graph that's decreasing and a decreasing rate? Now, obviously, at this point of time, I believe we're looking at the curve that's increasing at a decreasing rate. Okay, increasing at a decreasing rate. Just because of we still have people getting infected every day, but it looks like the rate is slowing down. But hopefully we're going to see people are recovering. So hopefully we can see the rate is decreasing. Okay, so the number of people are getting infected are decreasing at increasing rate. So more people are recovering. Okay. All right. Okay, let's put into a question. And I'd like to show how to do a certain question using this idea. Let me pick a question from the textbook. Let's see if that works. Oh, it's working. That's pretty good. Side by side, so I can do the questions there. All right, perfect. Okay, I just need to add another page. All right, let's pick a question. How about we try question 11? Okay, question 11. I don't think I can mark on this textbook. No, I can't. All right, so question 11, which is this question here. It says the scientists studying an insect colony estimate the number of insects, NT of the insects, after T months to be NT equals to A over 2 plus E to the power of negative T. When the scientist begins measuring, the number of insects in the colony is estimated to be 3 times 10 to the power of 5. And then a question asks you to find A. All right, so that question looks like pretty easy to do. We'll start with the first one. Okay, question 11. All right, let's make this maybe smaller so I can write. Okay, so firstly, NT. Write down the formula. NT is equal to A over 2 plus E to the power of negative T. Right, the first condition to give us is when the scientist begins measuring. All right, begins measuring means when T equal to 0 initially. The number of insects to be, so A is the insect, and A is equal to 3 times 10 to the power of 5. All right, and the question asks us to find A. All right, so sorry, not A here, because we are finding the A, so N is equal to 3 times 10 to the power of 5. Okay, so what we do here is we're just going to do a substitution. So that gives us 3 times 10 to the power of 5 is equal to A over 2 plus E to the power of 0. All right, remember you're substituting 0 for T. All right, so that gives you 3 times 10 to the power of 5 is equal to A over 3. Okay, 2 plus 1 is equal to 3. Now, after you finish that, you're going to work out what's A. So A is equal to 3 times by 3 times by 10 to the power of 5. So that becomes 9 times by 10 to the power of 5. So that's what A is. All right, let's read what the second question is now asking you. So the second question, the question says, what is the population of the colony after 1 month? All right, so 1 month later, what is the population? All right, so that should be quite easy here. All right, the reason for that is just because we have the formula, and then all we have to do now is simply do some substitution to work out the answer. All right, so that's question 11, part A, part B. Now the formula is NT is equal to 9 times 10 to the power of 5 over 2 plus e to the power of minus t. Then the question asks us, what is the population after 1 moles? All right, so t is in terms of moles, right? So when t is equal to 1, you want to work out what's n. All right, so n bracket 1, that just means when t equals to 1, right? Is equal to 9 times 10 to the power of 5 over 2 plus e to the power of minus 1. And all you have to do is use your calculator to work out the answer here. All right, so 9 times 10 to the power of 5 divided by 2 plus e to the power of minus 1. All right, so the answer is this. And we're talking about the number of inserts, okay, or the population. So we can do the rounding to, all right, if we were to talk about the nearest, all right, then it will be 380,087. All right. That's how you do it, okay? Question C. How many inserts would you expect to find in the nest after a long time? Now, here comes a very interesting question. After a long time. It didn't really say anything about a time. It just says a long time, after a long time. How do we do that, all right? They ask us to find the number of inserts after a long time. What does that mean? Right? Whenever the question says long time, or when the time becomes unlimited, all right, or infinite, that just means when t approaches to infinitive. All right, so basically you're just using a limit. T approaches to infinitive, 9 times 10 to the power of 5 over 2 plus e to the power of minus t. Okay, all right, and then you can do a substitution. That becomes 9 times 10 to the power of 5 over 2 plus e to the power of negative infinitive. Now, limit when t approaches to positive infinitive, e to the power of negative x. That is actually equals to e to the power of negative infinitive, which is equal to 1 over e to the power of infinitive. And e to the power of infinitive is equal to infinitive, right? A very large number. So you've got 1 over infinitive. That answer is 0, okay? It's approaching to 0. So therefore, that tells you the answer would be 9 times 10 to the power of 5 divided by 2. So you can write 4.5 times 10 to the power of 5. So eventually, this is going to be the population of the insect. All right, question D. Find an expression for the rate. So we're going to differentiate again, at which the population increases over with time. So we're going to differentiate to find the rate. Yeah. All right. So let's just start with a new page. Question D. So nt is equal to 9 times 10 to the power of 5 over 2 plus e to the power of minus t. All right, now we are going to find the rate. So we need to find an expression. So we need to differentiate, okay? So dn over dt is equal to. All right, so how do we differentiate these? That looks pretty hard. It's a fraction. So what do? Is we're going to use the quotient rule to differentiate that if you want to. Otherwise, you can use the product rule, okay, by changing the denominator to the negative power. Or the chain rule. So I'll use the chain rule. Alright, so how about we change this one into 9 times 10 to the power of 5 bracket 2 plus e to the power of negative t to the power of negative 1. So when we differentiate that, that becomes a bit easier to do. That's minus 2. And we're going to times by the derivative of inside brackets, okay? Which in this case is negative e to the power of minus t again. Alright, now let's simplify this one here. We have 1 and 2 negative, right? When you combine these two together, that becomes 0. And then we have 9 times 10 to the power of 5, e to the power of minus t over 2 plus e to the power of minus t to the power of 2. Alright, because that minus 2 as a power, I change that into a fraction. Okay, alright, so that's D finished. Now, we're going to move on to the next one. Okay, question E. Now, question E tells us to hence show that dn over dt is equal to another expression. Okay, how do we show in this case? What do we do? So we need to show dn over dt is equal to m bracket 1 minus 2n bracket, over 9 times 10 to the power of 5. So what do we do here? a couple of things you can do with this, right? What you can do is you can start with this one. Let's start with that. dn over dt is equal to n minus 2n over 9 times 10 to the power 5. Right, so this is what we need to show. Alright, this is what we need to show. And this is the previous answer we get. Alright, so we need to show the previous answer is now equal to this answer here, but in terms of n. Now, what's n equals to? N is equal to 9 times 10 to the power 5 over 2 plus e to the power minus t. Alright, that's what n is. Okay, alright, so what do we do here? Alright, so what I can do is I'm still thinking about, should I start from the previous answers we got and start to prove it to the final answer here, or should I just use the answer to prove the answer, whether this is correct? Alright, if we start from here to do it, alright, if we start from the right hand side and do some substitution, we're going to get 9 times 10 to the power 5 over 2 plus e to the power minus t, 1 minus 2 times by 9 times 10 to the power 5 over 2 plus e to the power minus t, and then everything that's over 9 times 10 to the power of 5. Alright, then these two cancels out. Alright, and then what we're going to do here is we multiply everything inside. So that gives us one different color, 1 over 2 plus e to the power minus t, brackets 1 minus 2 times by 9 times by 10 to the power 5 over 2 plus e to the power minus t. Alright, and then let's see if we can get to the answer. Not yet. Okay, we need to continue. Alright, so make it the same denominator any times. Alright, so you get 2 plus e to the power minus t minus 2 times by 9 times 10 to the power 5 over 2 plus e to the power minus t square. Okay, let's compare the answer. That's not the answer we have. Alright guys, back to this question here. Now previously I can't do this question is just because I realized there's a mistake in the textbook. So for exercise 9D, question 11, question 11E, if you pay attention to this one here on a question on the textbook, they use this one to be 1, right? This is not 1. They made a mistake and that answer should be A. Okay? That's not 1. So everything we did here is not correct just because of that mistake here. Alright? Yeah, unfortunately, that's the reason I can't do it. So now all I have to do here is just simply replace the 1 by 9 times 10 to the power 5. And then we can just remove that one here. That's 9 times 10 to the power 5. And then everything should work now. Okay? So that's where the mistake is. And this is really annoying because of the textbook making a mistake. The actual question is not even correct, and that's why I can't do it in the first place. So 2 times 9 times 10 to the power 5 minus plus 9 times 10 to the power 5 e to the power minus t minus 2 times by 9 times 10 to the power 5. So now everything works perfectly. If you cross these two out, all of the answer here now is the right answer, and that's the way to do it. So yes, unfortunately, the textbook made a mistake. So place 1 into the question here. You just have to be very careful. Not every question in the textbook is right, and that was the mistake here. Okay, so that's how you do this question here. All right, thank you. Thanks.